Hello, everybody. So, you're going to have a test on Monday. Yay. Well, let's do a review. So, for each problem, I want you to pause, try the problem, then press play. And then continue in that fashion. To get credit for today's work, just upload the last problem that we do. That's all you need to do. Okay, so first we talked about simplifying radicals. So we'll start there. So 1,000 we know is 100 times 10. Square root of 100 is 10. And then square root of 10 does not simplify because there's no perfect square factor. So that's it. Number 2. Do the following side lengths form an acute, obtuse, or right triangle. Show your work. This is the converse of Pythagorean theorem problem. So remember, if c squared is greater than a squared plus b squared, it's an obtuse triangle. If c squared equals a squared plus b squared, then it's right. And if it's less than, it is acute. And then you just have to make sure that the two smallest sides added together must be greater than c to even make a triangle. That's the triangle inequality. So we have 12 squared, and we want to know how does that compare to 8 squared and plus 10 squared. So 144, and then we have 64 plus 100 is 164. So this will be an acute triangle. Number 2. Remember, pause the video, try them before hearing the explanations. Okay, so letter A, this is a 45, 45, 90 because they tell you it is isosceles. So we know we have A radical 2 as our pattern. So that means 11 is the A radical 2. So isolate the A. And then multiply by radical 2 over radical 2 because we need to rationalize all denominators. So 11 radical 2 over radical 4, which is 2. And then y will be the same, 11 radical 2 over 2. Letter B is a 30, 60, 90 right triangle because they told you the angles. Remember, if they don't tell you the angles, do not assume the measurements. So that would be A radical 3 is the longer leg, and then the hypotenuse is 2a. It's easy to get those mixed up. So 24 is the 2a. Divide by 2, a is 12. So that's n. And then therefore the longer leg is 12 radical 3. All right, and letter C, do not assume it's 30, 60, 90. It is not. So, this might be one of the triples. So you could technically use Pythagorean theorem to solve for P, but we also have a shortcut. Since these have a common factor of 7, you divide by 7 to get 3. 35 divided by 7 is 5. So then P would be a multiple of 4. 4 times 7 is 28. Letter D. So we're finding the length of CD, but we have a couple 30, 60, 90 right triangles in here. This would be 60, 90, 60. Those are complementary, and then 30. And then the big triangle itself is a 30, 60, 90 as well. So now we just need CD. So we have A, 2a is the hypotenuse, and then a radical 3. So 2a is 7 radical 3, so divided by 2, a is 7 radical 3 over 2. Now we want CD, so we multiply that by radical 3 to get CD, and that would be 7 times radical 3 times radical 3 is radical 9 is 3 over 2. 21 divided by 2 is 10.5. And letter E, finding the area of the rectangle. All right, so we have the height is 10, we need the base. So, special right triangle. They're both even, so that's 13, 5. Oh, it's a 5, 12, 13 times 2 is 24. So the area is 240 square, whatever, square units. F, find the side lengths. So 30, 60, 90. So label A radical 3, 2A. All right, so A is 4 radical 3. So then the R will be 4 radical 3 radical 3. 12. And S will just be 2 times 4 radical 3. 4 times 2 is 8 times radical 3. Very good. And then, this is a fun one here. So let's see. 30, 60, 90. All right. A radical 3, 2A. So the Y will be 3 radical 3. The Z will be 6. Okay. Now we have a 2, an X, and a 6. That is, I better make sure. That will not be a special right triangle. So how do we work with that? Pythagorean theorem. So 2 squared plus x squared equals 6. 4 plus x squared, 6 squared equals 36. Minus 4 to both sides, x squared equals 32. X is the square root of 32, which will be, 16 times 2 is 4 radical 2. So x is 4 radical 2. It's not a special, you have to do it out the long way. On the test, you're going to leave everything in simplest radical form unless it says otherwise. And then W will be, so this is a 45, 45, 90. So A radical 2, so it's 4 radical 2 is 8. Oh, here's one of those circle problems. So find the coordinates of point A without a calculator. So you make the right triangle inside, because any point on a circle can be made into a right triangle if the circle's around the origin. Here's the x coordinate and the y coordinate. You need the radius. That tells you the radius is 4. And this angle is 45 degrees past 180. So it's a 45, 45, 90. So it's A radical 2. So if A radical 2 is 4, A is 4 over radical 2. Simplify the radical, of course. 2 radical 2. And since we're in quadrant 3, the ordered pairs are both negative. So here we have 3 points that form a triangle. Classify the triangle. So you can sketch it. Let's go ahead and sketch it. 2, 5, 4, 1, 5, negative 6. Okay. So you can kind of tell from looking, but you have to show your work on the test. So let's prove it. Let's prove the classification. So we're going to use distance formula. I'm going to change the color. All right, so we have square root. So x2 minus x1 squared plus y2 minus y1 squared. So that's 4 plus 16 square root of 20. So that's negative 4 times negative 4, so positive 16. So that one's the square root of 20. Now let's do the next one. Okay, 1 squared, that's 1. 49, that's square root of 50. You could simplify the radicals, but I'll just leave them because it's not necessary for this problem since we're just classifying. So then let's do x2 minus x1 squared, y2 minus y1 squared, 9 plus 121, square root of 130. So they're all different lengths. Okay, so therefore it is scalene. And then to prove for the angle, it looks like an obtuse triangle. Well, let's prove it. So you're going to say you have to compare c squared versus a squared plus b squared. All right, so the biggest side is square root of 130 squared. That's 130. And then square root of 20 squared and square root of 130 squared. 20 plus 130. Oh, sorry, that should be a 50. So 20 plus 50 is 70. That is less than 130. This is an obtuse triangle. So it's scalene and obtuse. Actually, before we do this one, I want to do a box problem. So the dimensions of a box are, let's do 3, 4, 2. Find the biggest stick that could fit in the box. Longest stick in the box. Okay. So remember, the longest stick doesn't just lay flat on the bottom of the box. It goes from one corner to the opposite corner. And to solve for this, you're making a stand-up triangle. So we could actually get this bottom piece first. So that's Pythagorean theorem, 3, 4. Oh, that's a special, 3, 4, 5. So the biggest stick laying down is 5, but we know the stick could actually stick up a little bit. So we have 5 and 2. So you have 5 squared plus 2 squared equals c squared. 25 plus 4, c squared equals 29. C equals the square root of 29 inches or whatever, units. So that's the biggest stick that could fit in the box. You'll have one of those on the test, so write this down. Okay, let's finish with this hard one. This is the only one that you need to upload your work. So these points are points on a circle. Calculate the equation of that circle. I'm going to do a quick sketch. So we have 11, 6, 9, 2, and 5, 4. So those points are points on a circle. So in order to get the equation, what is it that you need? You need the center and the radius. Okay? Now, let's think about how we found the center of a circle from points. Think about construction. What did we do? Oh, the intersection of the perpendicular bisectors. Oh, I wanted to change the color. Here. The intersection of the perpendicular bisectors will be the center of the circle. So what I'm going to have you do, I'm going to post the solution separately for this. I would like you to calculate the equation of the perpendicular bisector of two of them, two perpendicular bisectors. So remember, let's talk about how you do that. You get the slope between 2 points, and then the opposite reciprocal. That gives you the slope of the perpendicular bisector. And then what point do you plug in to mx plus b? You plug in the midpoint. So you're going to do that for any two, and then find the intersection by solving the system of equations. And then that will give you the center. Then the radius, you would use distance formula from the center to any point. And then x minus h squared plus y minus k squared equals r squared. So give this a try, upload. The answer is also posted in today's lesson. Email me if you need help. You will have one of these on the test. Have a great day.